procedure for the representation is same. So here to represent Daniel cell or any galvanic cell, we are using one rule, that is lone. So what is lone? Lone rule. Okay. So lone means left side. Okay. So the electrode which undergo oxidation, we have to write to the left side. Okay. We have to write toward the left side. So we are in diagram also we have taken this zinc electrode to the left side. Okay. So L O A N. Okay. Here I will write R. Then again R, then C and P. So L for left side, R for right side. O for oxidation, this R for reduction. A for anode, C for cathode. N for negative charge electrode and P for positive charge electrode. So this point you have to remember, lone and RRCP. If you understand this lone, then you can automatically remember this RRCP. R for the right side, R for the reduction, C for the cathode, P for the positive electrode. So the cathode in galvanic cell, the cathode will be positive charge, anode will be negative charge. Okay. Then, so to represent in a single line of Daniel cell or any galvanic cell, we are taking the electrode which is left hand side, that is what? That is zinc, which is in solid state. We are showing the separation in between the zinc plate and this zinc sulfate solution by a single vertical line. So this Zn zinc sulfate solution. Okay. Then after that, we are showing the separation in between this one electrolytic solution and another electrolytic solution by a double vertical line. And after that, we are writing the second electrolyte of a second half cell. Okay. Again, the boundary between the copper sulfate and this copper we are showing by a single vertical line, and copper is in solid state. So this is the complete representation for a cell, Daniel cell or galvanic cell. So single vertical line means the zinc rod in the electrode in electrolytic solution. Double vertical line means there is a separation, that shows the separation in between the two different types of conducting material, that is electrolytic material. Okay. So this is the complete representation of Daniel cell. Okay. Now we will discuss the electrolytic cell. Electrolytic cell. Again here the electrode we are using. Again the electrolyte material we are using. Okay. So example is purification. Purification of impure copper. Okay. So here we are using only one part. For example, so if you want to do the purification of this copper, then we are using the copper sulfate as an electrolytic material. Okay. Suppose this is the one copper rod. Okay, and this is another copper rod. and both are deep enough. Okay. This is CuSO4 solution. Okay, and see now what I am doing. Okay, so this is the battery as source of electric current for the refining of copper from the impure one. So this is the positive terminal of the battery, this is the negative. So the electrode which is connected to the negative terminal, here negative electrode, this is positive electrode. Okay, then so this rod is a rod made by the impure copper, which is we got from the extraction, different states of the extraction of copper from the copper ore. This is a pure copper rod which is already available. This process takes place in a large amount in an industry. Okay, in purification of copper. Okay, so then here this electrode, that is negative electrode. Okay, so what happens after passing the electric current? This from the impure copper, what happens from the impure copper? The copper ion goes to solution. So this copper ion, I am writing here copper ion. Okay, then this copper ion, again more copper ion also produced by the decomposition of this copper sulfate into copper ion and sulfate ion. So these all copper ions try to deposit toward the negatively charged electron. Okay, which is actual source of electron. Okay, no doubt. So these are the positively charged particles. Okay, all they goes to solution, and from solution to they will try to deposit on this negatively charged electron, which is already available, our pure copper rod. Okay, so no doubt after the complete reaction, what happens? After the complete reaction, the weight of this copper rod will be, weight and size of copper rod will be increased. Okay, it become big in size, you can say. Okay, and this impure rod will become like this. Where the copper goes, the pure copper from this impure rod goes in the solution, and from solution in the form of ion, then it goes, they will receive the electron and reduction takes place. Okay, and they will deposit here. So in the beginning of the experiment, if you take the weight of this impure rod and the pure copper rod, then finally again we will take the weight, then definitely we will get there is an increase in the weight of this pure copper rod, because from this impure, whatever the pure copper is there will go in the solution, and from solution it will deposit on the pure copper rod, that is this negative charge electrode. Okay, this is the construction of electrolytic cell. Example is purification of impure copper. Okay, thank you.